Hello guys, welcome on Tesla Eduventures. In this video today we are going to discuss the mean free path. So let us first of all, we know that the molecules move in the gases and their motion is random motion. In fact, their motion is governed by Brownian motion. So let us consider this molecule whose diameter is d, and obviously in a single gas the molecules are similar, so the diameter of the molecules in a single gas is same. So this molecule is also moving towards this molecule, and first of all we know that when they will collide, then they should be they should appear inside this area. So you can see that if d is the diameter of each molecule, then this is also d, and if we draw a circle around them with center this point, then this area of the circle A will be equal to pi d square. So for collision, it is necessary that molecules should lie within this area. So let us now consider a cylinder whose cross section area is this pi d square, and a molecule is moving from this position to this position, and it has taken a time t. So I can say that total length traveled by this molecule is vt, and the number of molecules, n, is the number of molecules per unit volume. So total number of molecules will be n into volume, and n will be equal to n into volume of the cylinder will be area into Vt. Okay, so this is the total number of molecules within this cylinder. Now we know that the mean free path, in fact if we talk about the mean free path, then it is the average of the free path traveled by the particles, and free path is the distance traveled by the particle or molecule between two successive collisions. So if we wish to find out the mean free path, then what we can do, lambda is the symbol for mean free path. Then what we can do, I'll use our next page. So lambda can be calculated by dividing the total length of this cylinder divided by the total number of molecules in this cylinder. Obviously, if we say that there are total number of 6 molecules within this cylinder, then the 7th molecule which is moving inside this cylinder and all the other 6 molecules are at rest, then there would be 6 collisions. So if we divide the total length of the molecules, total length of that cylinder with the number of collisions or the number of molecules present inside the collision, inside the cylinder, then we can find out the mean free path. So mean free path L will be Vt divided by that NaVt. So this is NaVt. Now you can cancel this V and V, but you should remember that this V is the velocity of any single molecule, and this V is the relative velocity of the molecules, because we know that molecules, not only a single molecule is moving, in fact all of them are moving randomly, and relative velocity V relative can be, now we also know that the velocities of each molecule is random. So let us suppose that these two molecules are moving like that, so relative velocity will be under root of v1 square plus v2 square minus 2v1 v2 cos theta. Now if we find out the average velocity, then we know that due to the fact that this v2 and this v1 are random velocities, so theta could range between 0 to 360 for any value. So the average value of cos theta between this range is 0. So v relative will be root of v1 square plus v2 square. And this due to the fact that V1 and V2 are equal in magnitude, because these two are random velocity of two molecules in a single gas at same temperature, therefore they would be same. So random speeds would be same, therefore we can say that V relative will be root 2V. So lambda will be equal to Vt upon neta A into root 2Vt. Now cancelling Vt with Vt, 1 upon neta pi d square into root 2. So lambda is equal to 1 upon root 2 neta pi d square. This is the mean free path, where this neta or n is the number of molecules per unit volume of this cylinder. And you can also find out the number of molecules per unit volume by PV is equal to nRT. We know that PV is equal to nRT. This n is number of moles, and PV is equal to n by Na, where Na is the Avogadro number and n is the total number of molecules, is equal to RT. So P is equal to n by V into RT by Na. And this n by V is the number of molecules per unit volume. So P is equal to n RT by Na. And obviously this n could be written as, now RT, R by Na is Boltzmann constant. So this is n is P upon KT. So you can also substitute the value here. So lambda can be 1 upon root 2 pi d square into n, where n we are substituting P upon KT. So lambda is equal to KT by root 2 pi d square into pressure. This is the value of mean free path of the molecules. Okay, and this is it in this video, and in the next video we'll be bringing some more concepts of thermodynamics. Thank you.